Hello.
Hello?
Can you hear me?
Yep.
Perfect. All right. Well, I see you have already uploaded a few things you want to take a look at.
Yeah, that was just my unit test for that unit, because I have to, take a retest on this unit, because I did really bad on the test.
Okay.
So I have to redo it. And I just want to study that test. I don't know if that will help me, but I think it will.
Okie dokie. My sound's got a little echo. I'm going to use earbuds here. Let's try that. Let's see. That's a bit better, I think. Okay, so, oh yes, we do want to take a look at this and do better. So let's start right from the first page here. Graph the following quadratic equations without using a table of values. Label each parabola. Okay, so what did you do on the first one? It looks like you started correctly. So from here we can identify the vertex, which you got at 2, 4. And then from there, what did you do? Oh, that's the one it looks like you got right. Oh, okay. All right, so when we're looking at this vertex form that we've got here, the key pieces that are super important from this, I'll just rewrite it over on this side, is that P value and the Q value, because that's going to give you the vertex, plus Q. So our vertex is going to come from P and Q. So your vertex in this first one has a vertex of 2 and 4. Because that's coming from the P value, that's coming from the Q value. From there, what we need to do, it says without using a table of values, I would argue it's always a little easier with a table of values. What we do know that wherever your vertex is you've got a line of symmetry. So you're going to have your symmetry line down the middle of these two. And then what I would probably do, see, if it were me, I would use a table of values to an extent. Because, yeah, normally what we would look at is we would look at a y equals x squared parabola. Whereas if I was to do a table of values with that, and our y equals x squared is always going to be basically at 0, 0 as an origin, and it's going to have that upward U shape like this, that it starts at 0, 0, that's our origin. If x is 1, 1 squared is still 1. If x is 2, 2 squared is 4. And if x is 3, 3 squared is 9. So that becomes like your base, what we call our base points. So if that's my base points, what we're doing based on this one is we are shifting our x values 2 to the right. So x we've added 2. Y says plus 4, so going up y to plus 4, we're adding 4 to the y values. What we're also doing is this 1/2. What does this 1/2 affect? The x or the y? Yeah, it does. It does. But if it's affecting how thin or thick it is, then it's basically affecting that y value, whether it's squished skinny or becoming wider. So this 1/2 is also multiplying by 1/2. Now there's also a set in how you do this. You have to do the multiplication before you do any addition or subtraction if that was a plus or minus. So I know it says don't use base points or don't use a table of values, but I probably would just to play it safe. If I was looking at my new coordinates, to all the x values I would add 2, so this becomes 0 plus 2 is 2, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5. If I then were to multiply, what is 0 times a half? And then I add 4, which is 4. That corresponds with our new vertex of 2, 4, where initially it was at 0, 0. So if we continue to do that with our y values, 1 times, what's 1 times a half? Plus 4. Okay, and then if I was to do 4 times a half, yeah, 4 times a half is 2. No, it's 2. 4 times 2 is 8, but 4 times 1 half is 2. And then we add 4. Yeah. We can see what we're adding here. We've added 1 1/2 each time. So even without doing the math, I could just say, well, the next one's going to be 7.5. If I went up... Oh, sorry, you're right. Never mind. Don't mind me. Because, no, I was thinking it had to be equivalent, but you're right. It's squared. It's an exponential function. So no, I need to actually, I was trying to be lazy and not do math, but I have to. Okay. Boo. All right. Well, let's put in the 3 there. What's 3 times a half? And 1.5. Oh, no, sorry. We're doing the y values. Why did I just jump to x? Sorry, it was 9. It would have been 9 times a half. Plus 4. Yeah. So these would be our new coordinates. So on the graph, you've already got the 2, 4 at the vertex. If I went over to 3, I would be up at 4 1/2, which looks pretty accurate to where you are. If I went over to 4, and then I'd have to go up to 6, which you have a point here. That looks good. And then I've gotten 5, and I could go up to 8 1/2, 6, 7, 8, which is about there. So you're definitely on the right trajectory to then do your symmetry line and plot both of those. So as far as not using a table of values, I would argue differently. You can get the vertex, but you kind of need to get the other piece. So I would just say go with a table of values. Ignore it. Let's try the next one, because it doesn't look like you got that one. B. Y equals -2 x plus 3 squared minus 6. Okay, what is our vertex? Good, so I think you got that part. -3, 1, 2, 3, 4, 5, 6. Okay, so you did get that part. Good. Again, if we look at our base points from our original graph, 0, 0, 1, 1, 2, 4, 3, 9. These are always your base points on a parabola. What are we doing to the x value? Yeah. What is the value that basically, what was your shift on the x? Like, because you got to your vertex. What's the coordinates of your vertex? Yeah. So you shifted your origin from 0, 0 to -3, -6. Of the x points, the x value is going left 3. So we're going to subtract 3 from our x values. That's going to shift that new origin, that new vertex. What happened to the y? So that one we're going to take away 6. And again, if I do that here, although there is one more piece we need to do, and that is what's out front, because this also affects y. So we also need to multiply by the negative 2. Exactly. So 0 times negative 2 is still 0. But then we go down 6. So you got the vertex, right? That is our new vertex piece, which you got down here. Now let's take a look at some of the other points. What are our x coordinates going to turn into? Okay, now let's go through our y coordinates. If we did 1 times negative 2 minus 6 more. Okay, if we were to put in a 4 times negative 2 times, or not times, plus minus 6 more. Good. And if I was to put in 9, we definitely don't have room on our graph, but that's okay. We would have ended up with okay, so let's take a look based on what we have as far as much grid space. We can go to negative 2, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. A little bit off there, but not by much. A negative 1, negative 14, which we're not even going to be able to come down that far, but it will be down here somewhere, about-ish. So you didn't get any marks for that? Well, you did get a 5 out of 9. My guess is that each one of these questions is worth 3. And so you got a check mark on this. So I'm going to say you got the full 3 marks on this because your points matched up and you had the dot showing. My guess is you only got 2 out of 3 on this one, just because maybe your points weren't quite labeled or the dots weren't quite as visible. Like if I erase just what erase what I had. You didn't really identify a key dot. You only had the vertex and you drew yourself a downwards facing parabola. It is downwards facing because of the negative leading term, but there was nothing specific that jumped out here. So like I think if you had just labeled like a point and a point along with a vertex, I think that would have got you the full 3 marks on that. So I think you got 2 marks on this. C, you didn't draw anywhere on here. So what happened? Let's take a look at that one. I don't really have a ton of paper room, but you know what? I'm going to make it work. Okay, so that one is y equals 4x squared plus 16x plus 7. Oops, that's a bad looking 16. Okay. So what did you do? You factored out the 4 first, and that would have left you with x squared plus, well, if you factor out a 4, this would have turned into 4x. Plus 7 you put on the outside. No, you do need to put it in vertex form, and that's good, but what you didn't do is when you factored out the 4, you didn't change the 16. So, right, when you factor, you're only factoring these 2 terms. So dividing each by 4 leaves you x squared and 4x. Then I can put it into vertex form, and how do I go to vertex form from here? No, well now you're, no, because you factored it out. Now it's half of 4. Half of 4 then squared. right? So if we divide this by 2 and square it, what do you end up with? 4. So this would have been a plus 4 and a minus 4. Then how do I bring, once I have to pull that minus 4 to the outside of the bracket, what happens to do that? Yes, because there was something out front. So when I pull that out, 4 times 4, what's coming out here then is minus 16. Okay, so now what is my vertex form? Good. Yeah, squared on the vertex form. But yes, minus 9. That sounds right. Yes. So, all right. So we should be able to plot this then. It's kind of sucky they make you put it on the same graph that's already got a bunch of stuff. So that vertex would be like right up here at 2, 9. Is this parabola opening up or down? Right, so they really didn't give you a whole lot of room to do this one. Okay, The other thing that I'm noticing, which seems impossible, if I was looking at the y-intercept, what would the y-intercept of this equation be? Well, if you replace these x with zeros, what's going to happen? You just get 7. Yeah, exactly. And so here's the issue I have. 1, 2, 3, 4, 5, 6, 7. If it's saying my y-intercept is 7 and my vertex is at, oh, and technically, sorry, this wouldn't be plus 2, because remember it's x minus p. It'd be at negative 2. Why did I go up 9? I reversed mine for some reason. Say that again. Like when you're in this form? No, not necessarily, because your formula is x minus p, right? So like in the first one, you had x minus 2, which is why the x was a 2, because it was minus to begin with, and so this was just a 2. This one was an x plus 3. The only way this turned into x plus 3 in here is if this was x was a minus 3, which is why we went left minus 3. So it's actually, when you're looking at vertex form, because of this minus, your symbols really, if you have a plus in here, your x value is negative. So if I have an x plus 2, my x value is actually, the vertex is going to minus 2. And then to minus 9. My vertex is actually way down here. Which makes more sense. I don't know why I reversed that here. The reason I got caught off guard, because I was looking at it, if our y-intercept's 7 and this parabola opens up and if my vertex was here, that's not possible. It'd be opening down. And so I was like, well, that can't be right. And I don't know why, but I didn't look at this. My vertex here would be at negative 2, negative 9. The y value is the y value. You don't change that. If that's plus, you go up. If it's negative, you go down. But it's inside this x minus p that makes the difference. So this one should have had a vertex of minus 2, 9. Minus 2, minus 9. For this. Does that make sense? Okay. So, okay, now we have a y-intercept of 7. So I know that there's an axis of symmetry wherever that x is. So if I have an axis of symmetry for this parabola, and I'm crossing here, I would have another identical point right here. That would be enough to connect and come down to your vertex and come back up. You could make it even more exact, but since it didn't say using a table of values, I'm assuming that would have been enough. Otherwise, go to your base points. On X, you would subtract 2. On the Y, you would have subtracted 9. You would have also multiplied Y by 4. And then you could plot new points as well. Does that make sense? Do you want to go through with a table of values, or do you get it? Yeah? Okay. So I think on C, you didn't score any points because, for one, your vertex form didn't work out because you didn't, when you factored the 4 out, you didn't actually take it away from the 16. It's those first 2 terms that have to factor. Let's get you to factor one more of those. Just like make sure you got this. Let me pick a question. Let's go to PreCalc11 and get the computer to generate a question for me that will make sense. Okay, we want parabolas, quadratics, graph, quadratic, complete the square. Ish. This might do it. Except I want to jump a level. Okay, but that's just that's not really what I wanted. Okay, let me just give you one from here. Okay, I'm just going to give you a different one since I don't feel like searching for it. If I had y equals 2x squared plus 12x minus 3, how do I put that into vertex form? Yeah, we can. Because remember, similar to this last one, we factor out only within those first 2 terms. Right? I'm separating this. Well, if I'm trying to factor the entire thing, but completing the square? No, with completing the square, to put it in vertex form, you're only factoring the first 2. Okay, what are you taking out of these 2? You're taking out a 2, right? So then I'm going to end up with, oh, that's why you said it. Okay, you just didn't say that part. I was trying to mind read. Okay, yes. Now that minus 3 sits to the outside. We're not, my 3 is not very good. That's what we have left. Okay, now what would I do from there? I'll fix that. Okay, so that's going to make what? Good. Okay, good. Now what will we do? And if I'm going to pull it out, yeah, go ahead. Good. Perfect. I'm going to do it all in one step to avoid writing too much. All right. Then what happens? Hold on at y minus if all of these are plus. But still, think about how you would factor this. Let's go back to grade 10 math for a second. How do you factor this? If you were to ask to put this in factored 2 binomials, what would that look like? Exactly. So if that's what we're factoring here, there's no minus. Yes, the form in vertex form, I think what you're referring to is that a bracket x minus p, but all of that is telling you is which direction you're moving based on what's in here, plus q. Right? This still factored as x plus 3. My 3's are... Yeah. So what is my vertex? Exactly. And then from there, you could give yourself a rough sketch if you really wanted to. We're going to go to minus 3. Let's just say it's there. Minus 21 is going to be way down here somewhere. There's my vertex. Does this graph open up or down? And what's our y-intercept? Remember how you get a y-intercept. For it to cross the y-axis, x must be... So if you go back to your original equation and x is 0, y is... Right, so I know that I have a point at a y-intercept here of negative 3. We've got a vertex, we have a y-intercept. I could use my line of symmetry, which is also going to put a point 3 more units this way and 3 down, so that I have that symmetry line. And that would be enough to sketch your parabola. So my guess is your teacher may have just been looking for at least the vertex and the y-intercept for your mirrored symmetry without necessarily doing the table of values. Let's go back and take another look at that, because that would be my only guess. If you're not using a table of values, you're using the line of symmetry along with a reflection. So yeah, if you looked at your A, then your if you looked at a y-intercept, if x were 0, 0 minus 2, minus 2 squared is 4, 4 times a half is 2, 2 plus 4 is 6. You got the point of 0, 6, and you marked that off. And then you also did one on this side. So that's probably why, because you actually marked off those points. So I'm guessing, yeah, you didn't need to do a full table of values. He just wants, what is the mirrored reflection with the y-intercept? Although you couldn't really do that on this one because it was so far down. You had to find a point. So yeah, that's kind of not really fair either. Anyways, those are the two ways you can do it. Either with the line of symmetry mirroring the y-intercept if you have enough graph space, or then you can find actual points. Does that make some sense? Hopefully. Okay, do you get that, or shall we, let's move on to see what else you got, because it's probably going to repeat to some extent. Maybe. Okay, yeah. I'm just quickly scanning this because you didn't get any marks on this one either. Let's do it all. I think we have time. I just want to touch on a couple things here based on what we just did. If you look at number 5, you got your vertex in there, 2 and 5. I like that. It says question mark, what is the A value? So you have to figure out how are you going to get that A value there. So what I would do if I were you is I would choose any one of these points. If you were to pick a point, let's just say this point here. What's the coordinate of this point? It looks like -2, -3 to me. So I think all you would have had to do then is remember there's an a in this formula out front of this bracket. So substitute in the y value of minus 3, substitute in the x value of minus 2, and solve the equation. What is minus 2 more, and then squared? Okay, so 16a plus 5. How do I solve this equation? Okay, so then we'll end up with and now last step. So what does a equal? Reduce to you got it. So you had everything here but putting in the a value of 1 over 2 in front of in here. Negative 1 over 2. Make sense? So you had everything. The only thing is you had 1, 2, 3, 4, 5 points to choose from as an x and y coordinate that you could put any one into those, replace x and y, and solve for a. You were so close. Okay. With the other one, you've got a vertex and you have it passing through a point. So I like what you did there. You've got 4 for the y, you've got 0 for the x. Your vertex turns it into a plus 3 and 1. That's good. So where's the a out front again? You forgot the a. So if you were to put it all together, 4 now equals what? Okay, what is, not 3a squared, but 3 squared, right? 0 plus 3 is 3, 3 squared. So it becomes 9a, good. Solve for a. Well, I want a by itself. Oh, yeah, I see. Okay, so you're not moving 4. You're keeping the 4. You're moving that one. So 3 equals 9a, yeah. That's all right. I understood. I'm mind reading. That divide by 9. Good. Good. And so that reduces to, and that was it. And then you could rewrite the equation. So you've got y equals, we put in our a value first. We put in our vertex form, which is now x plus 3 squared plus 1. Just reusing that vertex you had in the original piece before you substituted the x and y. You just left out the a again. So both of those questions are the same. Don't leave out the a. All right, does that make sense? Okay, for the following quadratic, fill in the table. What is the vertex? So you had to put it into ooh. Okay, you did the same thing on the first page. Let's double check we don't do this again. When you're factoring the first two terms, yes, you're pulling out a minus 2. What now goes back into the factors if I'm only factoring that part? Well, if I'm factoring out the minus 2 from these first two terms, what's going to happen? What does this turn into? It's not x squared plus 8x if you're pulling out a 2. It'd be x squared minus 4, yes. Okay, so that was the same thing you did on the previous page, is you took out the factor, where was it? Here, you pulled out the 4 out of the x squared, but you didn't pull it out of the 16. That also has to divide by 4. So it's the same mistake you've made. Oops. If you're putting it, if you're gonna put it into vertex form, because that way you can answer the maximum, the minimum, what is the vertex. If you're trying to find vertex form, You're only pulling it out of the first two. Right, if I was factoring this as a trinomial with two factor brackets, that doesn't help me with what you're trying to graph or solve this way. So all of this vertex form is just the first two terms. So factoring out the minus 2, that becomes x squared minus 4x. Then what will we do from there? Which is, so we're going to have plus 4 minus 4. 7 sits on the outside, then good, because we're timesing it by the negative 2 that was there, so it will turn into a plus 8. Okay, and so what's our final vertex form? No, how do you factor x squared minus 2? Yeah. Yeah. So what is our vertex? Exactly. How do we know if we have a maximum or a minimum? Good. And since this is opening down, that's as high as those values get, that is a maximum. You got a maximum, well, if you got the vertex wrong, you're going to get the maximum min wrong, but you had the right idea. It is associated with the y value, but it would have been 15. Where do we get the line of symmetry? Same thing. You had the right idea. The line of symmetry comes from the x value, but your vertex was wrong. Which is why sometimes these questions are unfair, because if you get the vertex wrong, you're getting the next two questions wrong. And you're getting the, and you'd even get the range wrong. Although on this one, there's two reasons this would have been wrong, is because you got y being greater than or equal to 39, but it's not opening up, it's opening down. That was a maximum value, so it would be y is less than or equal to that value. So, and then from here, an easy one you left out, how do we get that y-intercept? Yeah, and if these are all zeros, what's left? That's it. Okay, good. You seeing the error of the ways? There you go. Well, you can't go wrong with domain and a parabola because it's always all real numbers. So you got 2 marks for the maximum and the domain. Unfortunately, if you had gotten the vertex right, then yeah, you would have probably had a full mark. So to lose 5 marks based on you made the same mistake on the first one, so don't do this again. Remind yourselves you're only factoring those first 2 terms out. So don't leave that one out. Okay, let's go to the next page. And then you also wanted to look at word problems. So let's just take a look. You did get that one. Rewriting this one. Perfect. Won't even worry about it. Okay, you factored out the negative 2. You did the same thing on this one. I see a pattern in your error. We're only factoring negative 2 out of those first 2 terms. You did not factor it out of it. So let's run it through in 2 minutes or less. Factor out the negative 2. What do we end up with? No pressure. Okay, if I go plus 5x, think about distributing. Minus 2 times x squared is minus 2x. Does a minus 2 times 5x give me 10x? What's wrong? It'd be negative, yes. Okay, that's the first part, factored. We have minus 7, stays to the outside. Now what? Okay. 5 divided by 2 squared is 25 over 4. Yeah, I'm just doing math in my head. Okay, so we got plus and minus. Then what? Mm-hmm. Good. Can we divide 50 by 4? I'm just going to check. 50 divided by 4, 12.5, but okay, is what it is. All right, and so last but not least, what is our final vertex form? So you left your -2 there out. How do you end up with a negative middle term but positive end term? It has to be negative. Yeah, and that's essentially what we ended up squaring. Okay, how do I get that together? We could do fractions. We can also just think of this as 12.5 if that's preferable to you. We can do it a fraction after. What is -7 plus 12.5? Not if you're starting at -7. Think of it as 12.5 minus 7. Yeah, plus 5.5. So that's what it should have looked like. So you forgot the -2 here. I'm surprised she didn't circle this because technically that should have been halved. You didn't get your squared term. So yeah, there's some stuff happening here. You could have done it in fractions. If we did it as a fraction, you'd have to put this over a 4. And if that becomes over 4, you multiply the numerator, you would have had 28. And then we could have left it in fraction form if we were so inclined. I'm going to cheat and use a calculator. 50 minus 28 is 22. So that could also have been as a fraction? Oh, okay. Perfect. Well, that's what it would have been if we left it as fractions. All right, let's go on to the last page. When do you get to rewrite this test? Oh, you got lots of time to review. Okay. All right, write a quadratic equation for the top edge of the umbrella if the origin is the highest point of the umbrella. The origin, oh, so there are different questions for each one. I see. Okay. You've got the initial formula. Okay, it's saying our origin is at the highest peak of the umbrella here. So what do we want to do for that? We've got a 40 centimeter handle. How tall is it from here to here? Okay. Well, there's quite a bit going on in this test, but I think if you just correct some of those simple mistakes, then even if you ran out of time here, it wouldn't have docked so many marks off. So here's what I'm looking at. We know the total height of this umbrella is 70. If the handle's 40, from here to here has to be 30. That doesn't look like a... that it's 70, yeah, it tells us it's 70 centimeters from here all the way to here. So if that's 40, and then that would have to be 30. Because that's the full 70 centimeters. Now, why is that important? I don't know yet. Let's see. Write an equation, a quadratic equation for the top edge of the umbrella above if the origin is the highest peak. So this is now our origin, which is telling us this is the parabola that we're graphing. So if that's my origin, this is my new 0, 0. So what do we want to do with this? We've got it 80 centimeters wide, which means I'm going to have 40 on this side and 40 on this side to split that line of symmetry. I'm just talking out loud as I'm trying to figure this out. Okay, so how does that help us? We have the origin is the highest piece. So do I want to do going, where was the initial origin? Is the initial origin this line or is it down here? Because what, well, if that's my origin, then, but then I wouldn't have like a P and Q value if I'm starting, if that's all considered 0, 0. So then is it just a negative for 1? It's a negative because it would be opening down. A negative A if X and P are just 0, then it makes no difference to put in a 0, 0 there, negative AX squared. Now how do I get the A? Can I take this as a coordinate? I could take this as a coordinate, I suppose, because this would be negative 30 plus 40 if that's 0, 0. That'd be going down 30, right 40. So if I took Y and put in a 40, negative AX is negative 30. Okay, let's try that. What would A give us if we did this? Yeah. Three squared is 9, so basically I had 2 zeros, 900, and but it's a negative A, so it'd be negative 900A. And yeah, because negative 30 times negative 30 is a positive 900, but this was a negative A because our parabola is opening downwards. So then, what is A then? Let's see. What is that going to create? Hopefully a nice number, but probably not. Ooh, negative 0.044. Not a fan. So I'd probably leave it as a fraction. Negative 4 over 90. Yeah, I'm just going to chop off a 0 off of each. So then my A value would be negative 4 over 90. X squared. So I think that's what we would do if this is our new origin of 0, 0, because if we're treating this as our 0, 0, I would have gone down 30, right 40 to get to this point. I need another point to determine my A to see how wide this umbrella is opening. And so as long as I identify a coordinate that I could put in for X and Y, solving for that A, I still don't have that P and Q because my origin is 0, 0 up here now. Does that make sense? Plug in a number, yeah, yeah, exactly. So this is my origin, my new 0, 0. I needed to have a coordinate of X and Y to put in to solve for A. Similar to some of the previous questions, like the first page when you were missing your A value on each of those. Remember all these ones? You didn't put in the A, and then you substitute in the X and Y. So it's like this. You've got to figure out the A. We don't have the P and Q like this one does because the origin is not 0, 0. It's a different origin. But if they're telling us the origin, then we treat it as nothing. So that's my guess. Okay, let's A. Whoops, that's not a pen. That's a highlighter. So how is this going to change then if now in B our origin is at the bottom center of the pole? Is at the bottom center. Bottom center. Are they talking way down here or up here? Is that a bottom? No, this would be bottom of the pole, I would think. I think this would be bottom. Right? Like here? Okay, so if this is our new origin, then we're going to have it's still opening down. So it's shifting this whole, that's what I'm thinking. That's what I'm guessing with it. Well, all of these, this whole unit's on parabola. So my guess is we need a parabola. The only shape we're going to get from a parabola is this umbrella. So my guess is yeah, we're just shifting this entire umbrella down here now as an origin. Which means if this has come down, it's still opening downwards. It's still going to be that negative ax squared. But I need a new point to substitute in which case it would be, how much did we come down from this point, I'm guessing? Just down 70 from the peak? Boy, this is a bit of a tricky question. I wonder if anybody's posted something like this. I'm going to Google it. Hold on, I'm going to write this question out. I've never seen one like this, and I've been doing this quite a long time. Write a quadra... Oh, really? Boo. Quadration for the top edge of the umbrella if the origin is at the highest point on the umbrella. I'll just start there and see if I can find an umbrella question. You said you had a question like this in your textbook? Inspiration. If you can, that would be good. I'm just trying to find something similar. So far, no luck. Don't see anything similar. Yeah, I can't find anything, but if you can find one, great, because I'm just going to, while you look for that, I'm going to think about this for a second. If I was shifting the origin down here, that, I'm assuming, is where we started from. I'm coming straight down 40 on the y, but I'm not shifting my x. That is still my tip. So my guess is y is coming straight down 70. It's still opening down. X is not shifting at all, which would make x 0. But then I can't have 0 times a because then I just have nothing. Ooh. Well, you know, and that's funny because if these are the hardest ones, they're only worth 1 mark each, and you lost 1 marks on a lot easier questions that I probably